Okay, so maybe I'll start, and maybe Prafula, you admit the participants as they come in, and we will start now so we don't finish late. So thank you everyone for joining this session, this AI for Good meetup session in New York. Last time I talked about the Nobel Prize in physics and chemistry given to AI scientists. I think it was a very big event. So I didn't plan the last call, but well in advance. But this one was planned. It's part of it's one chapter of my forthcoming book. The book is going to come out normally in January 2025, so just in a few months. So it's the chapter 4 of this book about LLM agents. So here the topic is, I think it's a very interesting topic, and a lot of opinions, and you will share your opinions. So maybe add to the for the Q&A. I'll be curious to hear from you. So can LLM models reason? Right? Can do the reason? So as you know, I mentioned the Nobel Prize. I mean, all the AI models, AlphaGo, AlphaZero from DeepMind, AlphaFold, ChatGPT. I think it was a big event. This is where really AI was on the map in the mind of everyone. Google has Gemini, Anthropic has Claude, Meta has Llama, and then you have the new OpenAI model called OpenAI O1 preview or O1. Not sure what's the status of it. So and this one can talk on your phone. So I don't know if you tried it. Maybe we'll do a demo at the end. But it's pretty nice, very responsive, and pretty impressive. So people are asking, is AI really intelligent, right? Especially like LLM models. Do they reason? Right? Or are they like just prediction machines? So went back to the dictionary. I mean, now nobody uses a dictionary anymore, so I Google it. So this is the definition of reasoning. Reasoning, the action of thinking about something in a logical and sensible way. Right? He explained the reasoning behind his decision at a media conference. Right? It means that if the AI gives an answer to someone, you should be able to explain like why he came up with the answer, right? To give the sequence of thought, how the reasoning behind the answer. And usually, for students in school, right? Teachers usually, when you take a test, right? Sometimes they ask you explain the reasoning. Even in math, they just don't want to the final answer. They want to see if you really understood, right? Or they use some sensible way to solve the problem. So you need to do reasoning steps. And sometimes in an exam, if you don't give the reasoning test, you don't get full marks, right? You get only like partial marks. So this is important. So it's a really legitimate question to know, do LLM models reason? The alternative is that they memorize everything and they just regurgitate, what they have memorized. So they don't really reason, they don't think, they don't just it's a big it's a super Google that just because it was fed the internet and just they give the answer because it memorized. So here, this is when people talk about prediction machines. So this is the example that I gave, is that these LLM models, I mean, I will not get to explain in detail how it works, but they are at least designed to predict what they call like next tokens, or tokens are like subparts of words, right? So for instance, if we say the quick brown fox jumps, then it's going to do like a kind of autocomplete, right? Like if it jumps over, above, and through. So on the model, it gives some probability, is what they call like greedy decoding. So it's like, looking like over like what is the most likely words to come up, is going to find over based on all the data that it has in its training set. So it has been trained. I mean, it doesn't use the training data per se. It was used to train the neural network, right, of the AI. Right? So somehow the neural networks memorize or remember or have this an idea of the probabilities of occurrence of words of tokens given some previous words, right? So this is like and people think that maybe it's just that it's just like predicting words and doesn't do anything like very deep. So here. I didn't mention who won the prize, but you might have heard that one of the winners, when you have like Geoffrey Hinton, who won also the Turing Award a few years ago, John Hopfield from Princeton, Demis Hassabis from and John Jumper from Google DeepMind. So I think it'd be interesting to hear from Geoff Hinton. If you don't hear the sound, just tell me. Sometimes it doesn't work, but so these are like a short videos from Geoff Hinton.
If you ask me a question, and then the first word of the answer is the next symbol, you have to understand the question. So I think by predicting the next symbol, it's very unlike old-fashioned autocomplete. Old-fashioned autocomplete, you'd store sort of triples of words, and then if you saw a pair of words, you see how often different words came third, and that way you could predict the next symbol. And that's what most people think autocomplete is like. It's no longer at all like that. To predict the next symbol, you have to understand what's been said. So I think you're forcing it to understand by making it predict the next symbol. And I think it's understanding in much the same way we are. So a lot of people will tell you these things aren't like us. They're just predicting the next symbol. They're not reasoning like us. But actually, in order to predict the next symbol, it's going to have to do some reasoning. And we've seen now that if you make big ones, without putting in any special stuff to do reasoning, they can already do some reasoning.
Okay, so maybe I can just stop my talk here, right? We got the answer, but I'll continue. But I think also when people are confused when they think about it's just like predicting the next tokens, is that as if I was saying, oh, this machine just predict, let's say in finance, this machine just predict the next price, the price in 1 second and in 1 minute and 1 hour. If you found a machine that could do that accurately, you'd be like God, right? You'd be like, if I could predict all the stock prices like in 1 second, right? Accurately, 100%, and just a prediction machine, I'll have like perfect foresight, right? So these will be like superhuman abilities and godlike abilities, right? So just predicting is, predicting well is not easy, and predicting perfectly will be like, like a miracle, okay?
If you ask me a question,
already. This I go quickly, but I think when the first ChatGPT came out, GPT-4, I think there was that very famous paper from for researchers from Microsoft called like Sparks of Artificial General Intelligence. So Microsoft are just users and investors in OpenAI, right? The company that did GPT-4. And they were really like impressed. And these are like serious researchers, right? These are not like people who don't know anything about AI. And you see what they wrote, right? We contend that this early version of GPT-4 is part of a new cohort of LLM models that exhibit more general intelligence than previous AI models. We discuss the rising capabilities and application of these models. We demonstrate that beyond its mastery of language, GPT-4 can solve novel and difficult tasks that span mathematics, coding, vision, medicine, law, psychology, and more. Okay, read the rest. So they were very impressed, and I think that many people were impressed. You also see the history of GPT, right? So the GPT-1 was 2018, right? So it's several years before GPT-4. GPT-4 was was last year, right? It was last year, and ChatGPT was like early last year. And now now we have like OpenAI 01, but already these AI scientists were very impressed in 2023, and I think the sparks of intelligence. So sparks means like it's small, right? It's not the fire or big fire, but it's there's something that is new. So this is like so you don't have only like OpenAI and ChatGPT. You have like a huge like a universe of LLM models of of large language models, right? So this is like it's like a nice survey on large language models. You can Google it. All these things you can Google them and you find them easily through Google. So you see that you have so GPT-3 in 2020 Codex that does coding also from OpenAI. You have Lambda from Google. I don't know if you remember when Lambda came, one of its engineers thought that Lambda was conscious. I think he lost his job. So I don't know if he lost his job or because of that he left he left Google. And then you have models from Llama from Meta, Facebook, Bard, and then you have Gemini. As you see, like like so many models like Palm 2, then Gemini, Gamma, Llama 3. So this stops probably like end of last year. Okay. Many some are like open source, or at least you can use the model like more or less like freely, depending on the license. More even the open source model don't disclose the parameter, don't necessarily disclose the training data, and sometimes don't even disclose the full parameters of the neural networks, but you can still like use them. And the proprietary ones like OpenAI, they're not open source. So when you think of reasoning, maybe it'd be useful to think in terms of how do humans reason? Okay. So if you look at the textbook, you Google it, you say like what kind of how humans reason, right? So you have different categories: deductive reasoning, right? So like if then else, like when you code it, like you draw conclusions from a set of axioms or premises, as seen in mathematics, right? From axioms and derived theorems, and so it's deductive. Inductive, that you try to generalize some specific examples to make broader statements. So you see like birds fly. Then you say like 5 birds, and all your life you saw like birds fly. And you say, well, birds fly, right? Maybe then till the day you meet an ostrich, but this is like inductive reasoning. Or the sun, you see the sun every day, and you have seen it like since day one, so you will assume that it will rise tomorrow. Probabilistic reasoning is more like based on observed data with some probability of things being correct, and this is maybe the most sensible reasoning, because sometimes I mean, there's some, I don't know, like mathematical truths and so on, but empirically, from what you observe, there's only like we can always say like it's very likely the sun is going to rise tomorrow, right? But we are not 100% sure, right? So there's so that view, that probabilistic view, is very attractive. Analogical reasoning, right? You compare a situation to a similar one, and you extrapolate, right? You say a few cars, the bigger engines tend to drive faster, and then so then you see like another car with like bigger engines, it's going to drive even faster, right? Abductive reasoning. So this is like to find, so maybe doctors are doing that, or many scientists try to do that. Like you find the most likely explanation for an event of observation. Or someone is sick. What is the most likely event that why is person like the person comes in December to see me? I'm the doctor. Like he has sniffy nose, coughing. Most likely it's like the flu. Right? Maybe because I've seen many like cases of flu. And so it's like adaptive reasoning. Another thing that humans have is these two types of reasoning, and you might have heard of Daniel Kahneman, who's also a Nobel Prize. He's not an economist, though. He's a psychologist, I believe. But he came up with like this system 1 thinking and system 2 thinking. System 1 is like automatic decision making, where you make decision without really thinking. It's like almost like automatically. That's what they call zero-shot reasoning, right? And in your daily life, many of your decisions are system 1 thinking, right? You wake up in the morning, you dress, you put on your shirt, your clothes, you leave your house, you keep the keys, you take the train, the car, you walk. These are all like rational decisions that you make, but they are done automatically, right? This is you don't think very hardly about it. System 2 thinking is more the deliberate thinking, right? Deliberative and reflective reasoning. So it's more, you have more international forms of reasoning. So you try to solve a math problem, right? You are a doctor, you try to find what is the disease that my patient is suffering from. That's more system 2 thinking. Interestingly, there's a book that I haven't read the full book, but I saw an excerpt in the Economist. So this is like Dr. Theodore Schwartz, who's a neurosurgeon. He's a brain surgeon, right? So he operates on our brains, right? His daily job, he operated many brains for many years. He wrote a book, and he said he was saying that. So the quote is, Dr. Schwartz believes that most of the feelings that we have arise spontaneously in response to triggers from the outside world. The brain then generates a plausible rationale post hoc for why a movement was made, a thought conjured, right? So what he says is that it's also related to free will, right? Do we have free will? So it's things that we don't have like free will, but it's really like we respond to stimuli, and we have thoughts, we make decisions, but really we make a lot of decisions even unconsciously, but maybe like it's like the system 1. And then we rationalize after. We say, okay, well, I did that because because this and that. But most of our thoughts are almost like unconscious and triggered, probably. Okay. So it's not that easy also to understand reasoning among humans, right? So this is also a caveat. So how can AI reason? So for AI, there are different kind of reasoning. So one would be like what we call zero-shot reasoning. So zero, it means like the number of the inputs that you give, examples that you give to the AI when you interact with ChatGPT or your favorite AI. So it means that a model generates some output, right? The answer with some reasoning steps, but without being giving specific examples. Then what we call like prompting. Prompting means that you provide a model with some questions, and sometimes you can also add like some context, right, or some examples. So you explain your situation. You have these things, and I would like to understand this better, right? This is the prompting. Zero-shot prompting is you don't give any examples, right? In context learning is that you give like some examples, and you explain the context of the thing. Say, oh, no, I need to fill up my taxes. I don't understand this. I'm going to show you this and try to explain it to me. Right? This is the context. In context learning is in contrast with the learning during like training, right? Or doing what they call fine tuning. Right? Training is like when you feed the data and you calibrate your neural networks. So this is like the learning to the training. This is what the big tech companies do, and it costs like millions of dollars to do it. So we don't do it. We do it on the smaller models. Or we do like fine tuning. It means like you have a pre-trained model, a model already trained, and you specialize the model. You train on a very smaller data set. Is what you call like fine tuning. So this is another way of learning. So it's learn to specialize on, let's say, like medical knowledge or these kind of things. Here in context learning, it means that it just learns from what you give it, like just a few examples or just the context, just in the prompt or in the text. That's what they call in context learning. Here, the two examples I gave here is like I just ask a ChatGPT, explain me the different like types of, explain me deductive reasoning, explain me inductive reasoning, and he can do it, right? He can do it very well. Right? So these kind of things, but you get all those things from the Wikipedia, so he can do that. So at least he can do as if it's understand what I mean, right? So explain me deductive reasoning, it gives me what is deductive reasoning. So that's kind of a concept of understanding. So because we cannot just like do like hand waving and say, okay, it reason doesn't reason. So AI researchers use like benchmarks. And usually when you read the AI paper, it's always like, we had this new model, these are the benchmarks, or they sometimes, very often they also invent their own benchmarks that is consistent with the models. We have, so it's good to be familiar with some of these benchmarks. And when new models come up in their research papers, there's always like the performance compared to the other models relative to these very often publicly available benchmark, right? And they will say, oh, we are better than XYZ, or we are better than SOTA. SOTA is state of the art, right? It's better state of the art on this specific data set of benchmark. So I just list a few of them. MMLU, so these are multiple choice questions for various subjects in the humanities, social sciences, hard sciences, other areas. GSM 8K, it's a benchmark of 8,000 grade school level math word problems, right, that you give to grade school students that they solve to assess a model's problem solving skills, right? Math is also another math benchmark. Human eval is a coding benchmark for coding. Drop is to test if an AI understand Wikipedia articles. So you have Wikipedia articles, questions and answers. What is the drop data set? MMMU, massively multilingual multi-class understanding. So it's a benchmark, but it uses different languages. So it's not only in English, but they're tens of, probably even hundreds, more than hundreds of benchmarks on this. The last thing that I must say, the problem of some of these benchmarks, if they are too small, there's a risk that this benchmark appear in their training set, right? That these models show the answers when they got trained, right? So then if they come up with the answer when you ask them, that's no surprise, right? Because they saw it's like you give the test to a student before he's taking the exam, right? So they call leaking, right? This data set have been leaking. So some of them, the most maybe popular ones probably have leaked already, right? So it's you have to be careful about that. GitHub too, for a lot of models are trained on GitHub. Some of the results are published on GitHub or data on GitHub. You have to be very careful about that. The GSMQ, so GSM 8K. So here, just a few examples. So here, Natalia sold clip to 48 of her friends in April, and then she sold half as many clips in May. How many clips did Natalia sell, right? And then you have the answer. She sold, so you have a 48 over 2. Clip in May, and then she stopped, and then it's the sum, and she stopped for the answer is 72. So you have all 8,000 questions of this type. So you see the problem, right? If the AI saw these question answers, it would just come up, oh, answer is 72, and had no clue how to solve it, but because it saw the questions before, right? So OpenAI, I mentioned OpenAI, and the OpenAI 01. A key difference compared to the previous version of OpenAI O, I believe it's called O, what it does explicit reasoning. At least it appears to reason, because when you ask OpenAI 01 a question, it takes a few seconds, right? It's just thinking. It tells you, oh, I'm looking at this, I'm thinking at looking on the web, and I'm doing this, I'm doing that, I'm thinking very hard. And it will very often take 30 seconds, 30 seconds, 20 seconds, 30 seconds and more to come up with an answer. So it's thinking, at least appearing to think. The previous model will just give the answer right away, right? It's no, there's no pretending of it. It might be thinking, but it doesn't say it's thinking. And according to OpenAI, so the numbers that they publish is that they're kind of improvements. So the different benchmarks. So we talk about MMLU, the math benchmark. For exams, that's the AP Advanced Placement Test, right, for high school. So they feed the exams, and you see how they score. PhD level science questions, right? Chemistry, physics, biology, and how they perform. In physics, they are maybe performing better than humans for this test. Then MLU MLU is very vast. It's different categories. So you said, for example, college mathematics, OpenAI is doing much better than the previous version. Okay. I mean, all these things we have to take with a pinch of salt, right? Because of data might be leaking. There's maybe they publish only the benchmarks and the model works. So you have always be a bit have a bit of grain of salt, not take everything at face value. But it's still impressive, and when you use it, you can see that it's impressive. So prompting is very important, right? So I said it was like inputs to LLM models. So they can serve like scaffolding or scaffolds for reasoning and guiding the models through complex tasks, right? You can see that these are like huge neural networks with like billions, some of them are close to 1 trillion parameters, right? So it's a huge universe, right? So where are they? How are they going to find the answer, right? And so this is a way to guide them. Say, oh, this is what I'm looking for, and then it will help to navigate through like its neural networks and to find the thing the most appropriate for us. For instance, if I in ChatGPT I answer the question, I ask the question in French, it's going to answer to me in French, right? I don't ask, say, answer to me in French. He just knows that because the question is in French, he's going to answer me in French, right? So this is, but because so implicitly in the prompt in my French answer questions, it knows that it has to switch languages. So we can do that, and really researchers have been using these prompts to customize the models, so to make the models smarter. So like educating these AI models and make them try to make them smarter, right? So we talk about the zero-shot prompting. You don't give examples. Few-shot prompting, you give a few examples. Chain of thought prompting. So this is kind of this is a very important concept. What it comes from this paper. I give you the link. It means that you give a few examples on how to solve it by decomposing the steps, right? And then you ask the questions, right? So here, for instance, the examples comes from the paper. So Roger has 5 tennis balls. He buys 2 more cans of tennis balls. Okay, each can has 3 tennis balls. How many tennis balls does it have now? Okay, and the answer is then the answer is 11, and then I ask the question. So here, I mean, so here we are standard protein. It's not. It wouldn't be like a zero shot, right? Just give the question, the answer, and you ask another questions. The chain of thought prompting, you in the answer that you provide, right? The AI. You say Roger studied with 5 balls, 2 cans of 3 tennis balls each is 6 tennis balls. 5 plus 6 is equal to 11. Therefore, the answer is 11. Right. So you give this to the AI, and then it comes out with the answers. This is what the chain of thought prompting. So you guide. You say, well, ChatGPT, I want you to decompose the problem to give me the steps. Give me the 5 plus 6 equal to 11. The answer is 11, and you see that the AI followed the instruction, right? The model output with chain of thought prompting is more detailed, right? So it said 3 plus 6 is equal to cafeteria 23 apples. You use 20 to make lunch. They had that 23 minus 20. 3, they bought 6 more apples. Therefore, it has 9. The answer is 9, right? And even the first case, the answer was wrong. There's a caveat for chain of thought prompting. Say, wow, it's fantastic. I should use it everywhere. And I think the current models already have like chain of thought prompting, by default. So even you don't very often you don't even have to do this kind of things. It does it automatically for you, right? Because everybody read these papers and they put them in the models, right? And they're all competing. So they can offer like chain of thought prompting. By default, it's even better for them. Right? So more models, you don't even have to do this kind of set of thought prompting. But a recent paper did study read like 100 papers doing studying shed of thought prompting, and found the benefit was really for math-related questions, not as much for like verbal questions, right? So this is something that you have to be aware of. Like chain of thought prompting works for like math, so like this, how many tennis balls like you have, or this kind of things. But it's like just verbal reasoning. It doesn't add much value, it's according to these researchers. So I'm going to go over like some kind of refinements. How do you make these models smarter? So I won't maybe go over all of them, but so first, least to most prompting, right? So least to most prompting methods. What it does, I'll just go over the examples. So the question is like, it takes Amy 4 minutes to climb to the top of a slide. It takes her 1 minute to slide down. The water slide closes in 15 minutes. How many times can she slide before it closes? Okay. So what you ask the AI to decompose the problem and to decompose the questions into sub-questions, right? So sub-questions first. How long does it take each trip take? And that is how you would reason to yourself too, right? If you had to do it, there's a pen and pencil. Okay, see that 5 minutes to climb, 1 minute to slide down. So how long does each trip take, right? To go up and down, right? So you say, oh, each trip takes 5 minutes. Okay. And then how many times can she slide before it closes? So you have 15 minutes late, 5 minutes, therefore 3 times, right? So what it does, what the listen was prompting, it does, so it does exactly that. It has the decompose into sub-questions, solve the sub-questions, and then use that to give the final answer. Self-consistency, it's something, it's also quite interesting that they use. So they, you know that these, you might know that these, this AI, they're a bit stochastic that you might, and you have a parameters that you can adjust that we call the temperature, right? So you want to then an AI to be more creative, you choose a high temperature. You want to be like more consistent and not as creative. So you don't want to have to be too creative in math, at least to make calculation. Temperature is very low. But if you have a moderate temperature, then the model is a bit stochastic, but it's trying to predict what you have. What we saw, you remember, like the fox jumps over or across, so it has some probabilities, but it's not like 100% that it's going to be jumped over, right? So you can use that to say, okay, I can sample different answers. I'm going to sample, let's say, like 10 answers, 10 different answers, do chain of thought like 10 times, and then I'm going to see which answer is the most consistent, right? Which answer come up the most often, right? So here the example here say that there are 3 cars in the parking lot, 2 more cars arrive. How many cars are in the parking lot? Right, so you go to the model, say like do it 10 times, chain of thought 10 times. Answer is 18. 18 appears more often. Therefore, the answer is 18. Right? So try to be consistent because you can be like a little bit unlucky, right? You do one draw, answer is 14 is the wrong answer. Right? So it improves the results too. Tree of thoughts. So tree of thoughts is so I won't go over the whole theory, but it's trying to mimic how the way we think, right? And when we think, at least it's to thinking. For instance, I don't know, you say, oh, I want to ask my boss for a raise. Okay. So let's say, oh, when is a good time to meet to set up a meeting with her? Right. And so I don't know, I should meet her beginning of the week, end of the week. At what time should I meet her? What I should propose? Should be online? I should be in person, probably in person. And when I meet her, how long should I ask for the meeting? Right? Should be half an hour, should be 1 hour, should be short, or should be long. And what should I say to present my case that I need to have a raise? Right? So you have like you go all this chain, and then sometimes you have dead end. You say, oh, should I meet her on a Friday night? Friday evening. Maybe it's not a good time, right? People are rushed to go back home and so on, and I might upset my boss, right? So I'll backtrack. I say, okay, Friday night is not great. Maybe Thursday night is better, or maybe the night is better. Maybe the morning is better, answer, right? So you backtrack, you test proposals in your head. This is what tree of thought is doing too here. So here it's in the case here it's a game, what they call a game of 24. Game of 24, you have four numbers, and you have to do arithmetic combination so that it adds up, or it combined, you get 24. So you have 4, 9, 10, and 13. How do you get 24, right? So you have different like thoughts, different ways to do it, right? 4 plus 9, 13. 10 minus 4 is a 6, and then you do, and then the AI comes up with like 39 or 36, right? And then you have to test it, right? So you can try to test it. The AI, does it make sense? Is it the number, is it close to 24, right? It's not 24. So I have to backtrack and try another combination. So it's like tree of thoughts try to mimic the human thinking in that case. And you see that it's not 100% accurate. For instance, for the game of 24, the get a score like 74%. IO is just a direct prompt, like no prompting. Right? Program of thoughts. This is interesting. So we know you might have heard, and you see that the AI, this ChatGPT, then sometimes they're not great at math, right? And so maybe addition, you can do it for small numbers, but when the things get complicated, that you have like differential equation, and so it's probably going to fail, right? And at the same time, it's normal, right? Even with just English, you cannot solve the partial differential equation. You can even like a quadratic equation just in your head. Sometimes it's not that easy, right? Big numbers, or even like the division, right? So division is big numbers. Not many people can do it in their head, right? And with the language, right? So what they do, they use a calculator, right? You say, okay, I want this. I need my calculator. I need to get the results, and that's it. It doesn't mean that I'm not reasoning. I'm not smart, right? So here the idea is the same, but here they use an external Python interpreter, right? So what they say, right, if something looks like something that could be solved by Python, by code, then call the interpreter or like write the program to call the code and solve it like this. So it's what they call like a program of thought, right? So here is the examples. Here is like a Fibonacci sequence. The rules that each number is equal to the sum of the preceding two numbers. It is for two numbers like 0 and 1. What is the 50th number of the Fibonacci sequence? If you do in your head, it's not easy, right? You have to add, okay, 1 plus 0 plus 1, 1 plus 2, 3, 3 plus 5, 8, and soon you'll be a bit confused, right? And even though you know the rules. And the 50th number here, the answer is like 32 million. So what the AI does, because it knows that it's something that it could be solved by a Python program. So they just write the program, right? So this is the program on the right. He said just the sequence of Fibonacci sequence that I is equal to the previous number plus the number before it, right? And then you have the answer and do a loop, right? For loop, and it gets the answer, right? Even the answer was not even 32 million, so it was like 12 million. Right? So just like by chain of thought, with that you're using that programming, he gets the answer wrong, right? And said like using Python, and it makes sense. Humans, we have invested lots of things to do algorithm programs and optimal control. So a lot of like a fancy theory. It's a bit strange to want to solve anything with like language. Okay, so this is also a way to improve the program. Reasoning with planning, so it's a bit complicated, but I'll try to simplify it for you. So chain of thought, you say, okay, a sequence of things to do, and you say, okay, AI try to do like the example I gave you, right? To decompose like that. What reasoning by planning, what they're trying to do is that they try to be a bit more sophisticated. They try to see, well, AI, you agree the state of actions, future, you have things that you're going to do. Essentially, it's like multi-step reasoning of thinking that you need to do. Then you have future state of the world, right? It could be like intermediate like values in the calculations, right? Then this is the next value. I'm going to do some more calculations, so new next step of action. Then I'm going to go to another state, right? So this is a sequence. What do we do? Planning states, actions, state, actions, state, actions, or even from the top, in fact, state, action, etc. And then I'm going to see, so it's also like a tree, right? And I'm going to ask the AI to value each intermediary, each value of these states, right? Am I going to ask the right direction or the wrong direction? And I'll be able to backtrack, right? If I'm going to a dead end, I find a solution that is wrong, right? Unlikely to be correct, I'm going to backtrack and revisit the tree, right? So it's like what they call reasoning or planning. It's very similar to, I know you're familiar with the AlphaGo, AlphaZero. This is something quite similar, right? So you know that AlphaGo and Zero, they don't play Go in brute force. It's not all the combination possible, and they choose the best one. So what they call exactly is they do something like that too. They have, it's what they call, in fact, Monte Carlo tree search, or MCTS. So they have this kind of trees, and they sample. They sample like path on these trees, right? So they don't sample the whole universe. They sample just like the most likely, a finite set of of path, and they take the one that gives the best value, the most likely to win, for the next turn. So this is the same thing. But what is interesting is that here the AI does everything. The AI does the action. The world model is within the AI. It's not an external world model. Right? We don't have like what they call a verifier. I don't have like a gold standard from outside. Here, what is a bit strange the first time you read about this, like the language model has its own world model in our head. A bit like us, right? We have our own like world model in our head, right? We don't, right? So they try to do the same. So this is also like a very interesting idea. This I'm going to go quickly. It's a bit like similar to it's kind of a same flavor. But what they do, so they try to encourage to have chain of thought, right? So give a few examples, right? So how you solve the quadratic equations and say, okay, this is how we do it, and then you solve it. X is equal to -1. So give examples, and you hope it's going to pick it up. Abstract of thought, what we call AOT, is that they say, well, these equations can be written as, ax2 plus bx plus c. It's quite generic, and a, b, c are numbers, right? And then you substitute, and these are the answers, and how you get the answer, right? And you hope that the AI is going to pick this up, right? So it's kind of more, so it's more abstract, right? It's more abstract thinking, right? And so many things is doing that. It can work pretty well. It's how we teach kids too. I mean, we can give an example and hope that they are smart enough to extrapolate. Or we give them, at least in France for math, we are taught this way, right? We're not given examples and say, okay, this is the rules. They say, okay, the French like the theories. Okay, this is how you solve ax2 plus bx plus c, and this is the solutions. Then apply it to examples, right? So we are taught this way, and we teach the AI this way too. I'm going to skip this and thinking LLM, but I'll just say briefly what it is. So here we ask the LLM to generate thoughts. So it's very surprising, right? So does it think? So I say, does the LLM think? So I say, okay, I'm going to ask the LLM, give me your thoughts. You ask the LLM to give you thoughts, it's going to give you thoughts, right? It's very obedient, right? So they say, give you like give you a calculation and give me what are you thinking while you are doing the calculation, and the AI is going to give you answers where they give thoughts. Are they really thoughts? I don't know, but is it going to give you thoughts? I'm thinking of this and that, and I give you the answer, and these are these thoughts. So these are what they call like thinking LLM, right? And some interesting, it doesn't perform uniformly well, but it's on some benchmark is improving on some previous models. So here also and very quickly, you can this is something that just came out. So people also were inspired, right? They're also interested in the brain. So they really heard of Daniel Kahneman thinking fast and slow. So they try to find to have agents that mimic AIs, that mimic the system 1 and system 2 thinking. A talker agent, a reasoner agent. A reasoner agent is system 2. System 1 is the talker agent, and you see how they calibrate. So you see that the system 2, it looks like the previous models, but they have they can reason, they can use tools, they go to the web, they can do searching, right? They do multi-step reasoning. So all the fancy models that we have, you put it in the reasoner, right? The reasoner agent, right? Here, and then right. The reasoners, and then you add the reasoners agent, and then you add the talker agent. The talker agent is like the one-shot prompt, right? You just give the answer. But so you have the reasoner, the system 2, they think a lot, right? He sort of like he had all these thoughts, he went look at all this data, beliefs, this and that, all these like fancy models into the reasoner agent. Then you give the answer, okay, this is my opinion, talker agent. Talker agent takes the output from the reasoner agent, then takes what it's believed, and then gives the answer to the user, right? And the user can give feedback such as a loop. It can learn. Okay. So one thing, so all these things are good, but not everybody is convinced. So Apple came up with a paper GSM symbolic. It's done by some interns, right? So I don't know. It's not the final answer. They call GSM symbolic. It's based on the GSM 8K that we've seen before for math test. So what they have been doing is like, well, does it depends? Maybe these results are specific to GSM 8K, right? And I told you about the risk of leaking, right? Maybe this data, these questions have been leaking on the internet already, so these models know the answers. So what we're going to what I need to do? We're going to generate our own GSM 8K, right? So they are going to use templates, what we have seen before, like this abstract thinking. So this kind of ideas, but we say like when the name, what is her family, and this and that. No, I'm going to generate a particular questions, right? And I'm going to sample the names from the sample of names from all the names in the United States and the world, family, on the X and Y, right? Instead of say study one blocks or 8 stuffed animals, I'm going to sample from 5 to 100, right, and these numbers, and I come up with like an infinite number of our own GSM questions. Okay, so what they did, right? So they created their own like GSM data set, and then they tested the existing models on these GSM data set that they have created. Right? So they have the same flavor as GSM 8K, but they are artificially generated. Also, so it's very unlikely that these models have seen these questions before, right? Because they are new and they were like stochastic. They are randomly generated. And what they find that the performance deteriorates. Okay, so here in terms of accuracy rates drops, right? So you see like gamma, they all drops. 1 mini doesn't drop that much. So the bigger models the more powerful models don't drop that much, but the smaller models tend to drop a bit more. You have it a bit cautious because the dropping is in terms of accuracy, and they don't all start from the same point, right? Some of them are like 95% accuracy, some of them like only 50% accuracy. So percent drop of these things. So you have to read the paper to understand all the details. Some critics say also that maybe some of the questions are not realistic, on even some of the questions, if you're even for humans, when you ask this kind of question, but it doesn't sound realistic, humans have trouble answering, right? So it could be why also the AI have trouble answering when the numbers don't make sense. For instance, say I have 100 stuffed animals inside, I mean, some kids have, but or something like some weird names of relatives or something like that. So maybe you might get the model confused. Something also like the same thing about that humans also fail on this test. So this is one a very simple famous test that psychologists use. They still use today. Very surprisingly, some of the recent papers still mention this test. I was curious about it. I think it was invented like a while back. I know it was the 60s. So say the question is like you are shown a set of 4 cards placed on the table, each of which has a number of one side on the color on the other hand. So one side is a number, one side is a color. The visual face of the card show 3, 8, blue, and red. Which card must you turn over in order to test that if a card shows an even number on one face, then its opposite face is blue? It's a logical test, okay? So when you do, you might have the answer or no. But when they did the test on human subject, 10% got the answer right. 10%, okay? So so humans sometimes, I mean, maybe it's that. So sometimes humans are not also that great at logical thinking, right? And we train all these AI models on our own data, the data on the internet and so on. So maybe it's not a surprise that also it's making mistakes, right? So I did that on ChatGPT, but I changed the numbers, right? To say about because ChatGPT was trained on Wikipedia too, right? So it saw the questions before, right? So I tried to I randomly generated the numbers, right? Odd and even numbers. I randomly generated the. In fact, I asked ChatGPT to generate the numbers, but I think it's okay. Randomly generated the colors, gray and white, and asked the same question, and it came up with the correct answer, right? So it's not So I don't believe it's just like memorizing like answers because you said before you can answer it, and if it deviates, you cannot answer it. I don't think it's true, right? One thing also is that the one critique I didn't mention in this talk is hallucination. Right? So you might have heard that AI models hallucinate. Right? They say nonsense, right? Things that don't exist. Right? But that also means that it doesn't just memorize, right? Because there's a lot of nonsense, but the nonsense it comes up with like you have like image model. They come with people with 6 fingers and so on. People with 6 fingers don't exist, right, on the internet. I don't think it's very common, right? So you just like hallucinate, or people with 3 eyes and so on, or like these like hallucination or things that don't make sense. These are not things that they copied from the internet, right? The thing that is extrapolate something that it knows and it wrongs, or it says that someone has a Nobel Prize but didn't get a Nobel Prize, but it happens that someone has a profile that is 99% correlated with people who got a Nobel Prize, so it makes that mistake, right? So it's not like that it's so that wrong answer on the internet. So it definitely doesn't just like memorize, it's not just like like what I said, a parrot, right? On like repeating things that it heard before. So he can extrapolate. He can come up with some new things, wrong things, but also like maybe new valuable things. So that's why I believe that there are some capabilities to reason. So it's fair the humor. So I said that it's not surprising that so it makes mistake, right? We are all imperfect reasoners. You get everything from Reddit, you get from everything from all the side, all the corners of the internet. But the advantage is fed a superhuman amount of content that we cannot master, right? There's no way you can read all the books published or read everything on the internet. It's not possible, right? We'll never be able to do that. But it has done it, right? It has room for improvements. All these models, so people like it's like very active field of research. I sample like a few papers, but you have like 10, 20 papers every week. Like hundreds of thousands of papers every year published. People it's like arm race to try to enhance these models. I'm telling you, these models are going to improve. They're not going to be maybe godlike, but they are going to improve. That's for sure. So there's room for improvement. They can use tools. We saw that they could use a pattern interpreter. They can use like proof checkers. So this is for math. I'll talk about this in a second. Coding platform, APIs, right? They're all kind of free APIs. You can use the internet. You can use Anthropic. Come up a few days ago. Right? It has a Claude can use the computers now. Try to mimic the usage of the computers, right? So if the AI can do whatever you can do with a computer, search the internet, look at your files, access your SQL database, program in Python, open an application, do search, use Salesforce, and so on. LLM has a lot of margin to make progress. Okay. And one thing that haven't seen much is that we have seen AlphaZero, probably because for LLM models, the cost of training is very expensive, is self-improvement. Because if you remember, after AlphaGo, I bet the Go chess player, AlphaZero was like superhuman because it played against itself, right? So it has a genuine answer. So he played, and he knew when it lost, when it won, okay? And then he kept improving. So it's like continuous learning, right? So the AI of today, they need something to improve, and they need to do something and to get the feedback. So we get the feedbacks, but these are just like ad hoc databases and so on. But if it could like check its own work, but 100% accurately, right? Not just like second guess. It's it's the right direction, because today when it's checking its own like homework, it's like second guessing. It's not like 100% accurate. But you could find a way to check 100% accuracy that the answer is wrong and come to improve. Then the AI then is like the path to a superhuman AI, right? Because there's no limit, right? It's like it can keep improving itself. So in math, Terence Tao, so he's one of the most famous mathematicians, Medal Fields winner. Right? Medal Fields is like Nobel Prize for mathematics. So he's not a fool, right? He's saying that I think in 3 years AI will become useful for mathematicians. It'd be a great co-pilot, right? You're trying to prove a theorem, and there's one step that you think is true, but you can't quite see how it's true. right? They have what they call conjectures. And you can say, AI, can you do this stuff for me? And you may say, I think I can prove this. Let's say in mathematics, a lot of conjectures that these smart people, they think they have a good sixth sense. They say this is probably true, but they don't know they have everything. There's 1% is missing, and AI can do it. I think AI will be smart enough to do that. And in math, at least in kind of math that Bernstein is doing, like formal math, you have these software, what they call theorem checkers, proofs checkers. So they can formally. So you have to you formalize this you prove, and you have an algorithm that check that the proof is logical. It goes there. So you see here the AI can generate proofs, use the theorem like a proof checker, say oh it's wrong, and then try to do a new proof, right? And it's very powerful. So maybe not in 3 years, maybe in 5 years, 10 years, or maybe 50 years. I don't know, but I wouldn't be surprised if you get like superhuman like AI mathematician because of that, because they can check their work, right? And they have a 100% accuracy of it's wrong or not wrong. Okay. So I'm going to just advertising a little bit my book coming up. It says the chapter 4, and they have other chapters. But maybe I stop here, and we can maybe take a few questions if you have any. I need to stop sharing my screen. So raise your hand, and we'll give you the floor. So it's a lot of things, but it's the reality. The research is huge in that field. So I try to give you a few flavor of what's going on. But it's very exciting area of research. Okay. Next step will be to talk about. I mean, the subsequent chapters is about the next chapter. Chapter 5 is can AI plan? Can they do planning, more long-term planning? So here, like so an example of planning, we have a stacks of blocks, and they are supposed to put one block over the other block, so you have to do the different steps. So this is the planning. After that, it's using tools, right? Can they use tools? You saw already they could use Python, so we can try to expand that. And then it's can you add a specific knowledge? So for enterprise, we have they call like a RAG, this retrieval augmented generations or access to database. Can you train an AI to access a local database, to read like specific documents in the company, also like client documents, technical documents, and so on. Only, and not to go use the internet for that. Okay. So I don't see any questions, but feel free to wish me to the meetup link, or if you have any thoughts and so on, or LinkedIn. I'm also on LinkedIn. You can connect with me on LinkedIn. Okay, so thank you very much, and talk to you next time. Bye.